Any other questions? Any other answers?
42.
Show must go on.
Yeah. Okay. Jean-Francois.
Okay, thanks. So hello everybody. So I'm here to share a few ideas I've been playing with for the last few years, and I wanted to share them with you and get some feedback about them. It's far less ambitious than the previous presentation you had this morning, so please do not need to ask too much from it. So here's the agenda for today. So who am I? I've been working for more than 25 years for HP, mostly in Grenoble, France. Yeah, so mostly in Grenoble, France, but also a few years in Roseville, California, and a little bit in Sunnyvale. And over my career, I worked part of the time on Windows, part of the time on Linux. And I started using Tcl about 10 years ago when I was working on a cluster management project. It was a cluster storage system. Now I'm working mostly on the Windows for the current project, so the demos I'll do will be under Windows. I hope you won't be too... I know that most people here prefer Unix, but all these examples will work just the same under Linux. So the thing I want to talk about is XML and other ways of looking at XML. So I'll just start for a minute with a crash course about XML. I know most of you know it already, so I'm sure you will learn nothing. But so basically, so it's a standard, and it's today it's the most popular standard by far for representing structured data in storage and also in network protocols. So I'm saying that mostly for the vocabulary so that you can understand then what I proposed. So you have the notion of well-formed XML, where the data is a tree, and so you have nodes and so on, nodes and elements, and so the structure of the node, of the elements look like this. So all the examples will be like this in green. So. Now, the structure of the XML elements, you have tags, or a name of the element, then attribute names, values, a number of attributes, and the content of the element, and then the closing part. And you have a lot of rules which give little details about the syntax and the acceptable characters and so on. And there are very strict rules, and I think that's why the XML specification became so popular, because it's so well defined. Okay, then you have a few other special syntax elements that are listed here. Just for one detail, for example, for the entities, you have just these 5 entities. So contrary to HTML, which has far more entities available, in XML you have only these 5 that are usable. The last one is from HTML for iterations. Okay. So the whole point of what I'm talking about is the simplicity. The XML specification lists about 10 goals, and 8 of these 10 goals can be basically they're about simplicity. They want to make the thing simple. And is it really simple? Well, unfortunately, it's not. One thing that proves it is that the specification itself is several thousand lines long. So contrary to TCL, where you have about 12 rules which define everything, here you need to read several thousand lines. So for all people who have to work with XML for their programming jobs, in practice it's simple when you have to read a very small piece of XML, and if you have to read a big one, it's very difficult. So as an example, this is a typical heartbeat configuration file that I had to work with for the Lustre clusters. That's the second half. And I showed a simple one that would fit on 2 slides. We had some that were much larger on large systems with lots of services. So for many, many years, I have been studying what the alternatives were. And because many other people have complained about the complexity of XML, like I did, and many proposed alternatives. The most popular of these alternatives by far is JSON, which is used by many internet websites, for example. And so I've rewritten as an example in JSON the example that was a few slides back, with a little database of countries and states and so on. So I really think this is easier to use than XML, because it's much more readable the way this than the previous one was here for an XML. The difficulty with XML is because of the closing tags and all these extra characters that touch the data, make it difficult to read. And even the TCL community has proposed a few things. A couple of years ago, I found by accident on the wiki that other people have proposed things. The second one is actually very similar to what I will be talking about, which something I have. Okay. So for my job, I had to design lots of management scripts which were managing the clusters and monitoring them and so on. And I was sometimes stuck by compatibility issues which forced me to use XML for exchanging the data. And at other times I was doing my own protocols for monitoring, for example. And with time I began to question whether we had to give up compatibility if we wanted something more simple. And I thought that all data trees were fundamentally equivalent. And so I began to search for something that could represent XML data tree in a more friendly way, but still be compatible with XML data tree. And eventually, about 6 or 7 years ago, I finally found a way to do it. And here's what I'm proposing. The idea is to represent. So here's data that's coming from a KML file, that's a Google Earth place mark. And to the right, it's the transformation of the same data to using the rules I'll be presenting, and that shows how it looks once it's transformed. And it's exactly the same data, it's just the presentation that's different. And as you see, it's much easier to read on the right-hand side the important information because it's not buried in the markup that it was in XML. So I was experimenting with this. Yes,
I notice the attributes are identical. You haven't done any translation on the attributes.
that's correct.
And why didn't you use key value pairs for attributes?
Because I experimented with that actually, and it makes when you have many attributes, it makes the output less readable.
However, it'd be compatible with pickle lists.
It would. But my problem, the problem I had to resolve was the readability of the file. So my problem was when something goes wrong, and you have to dig into the packets that were exchanged. You have to dig into the logs, and you have these huge logs with lots of data, and you want to find what is the wrong value somewhere. And if you have pairs of name values, and well, when they are both strings, you have word 1, word 2, word 3, word 4, word 6, and so on. And if you have too many attributes, you lose track of which is the name and which is the value. Whereas when you keep the initial XML encoding like this, it's easier to find the.
One potential solution would be to put a dot in front of each name.
Well, I know there are many alternatives, okay, but I'll go on, and you can see afterwards why some of the things. So very quickly, so here are the rules. So basically, the elements. So I call that simplified markup language, but it's XML database. It's just a different presentation. So the elements end at the end of the line. So these rules are almost the same as integral. And they work well because in most XML files you have one element per line. So this avoids like you rarely have semicolons here. For the attributes, so I was going to say, but I've already said it. So I chose to keep the XML syntax because it's more readable. For the content data, I chose something similar in spirit, I think, to Tickle, which is that you can remove the brackets if there are no spaces. That's the fundamental idea. So when you have a data block, it's within braces, and inside the data block, everything behaves recursively. So you can have multiple, either a text block or an inner element separated with semicolons. But if you have just text, you can show it with you can remove the braces and have just the quotes, and you can remove them. And that's what makes the output very readable. And for the rest of the markup, after experimenting with many alternatives, I chose to go like this way. For the XML, for the HTML comments, I use a pound sign, like integral. But the difference is that if you have two dashes, it's the beginning and the end of a multi-line comment. For C data sections, I tried many alternatives, and I chose to use this notation for symmetry, and also because it was by far the simplest one to explain, because of problems with escaping whatever border character you choose. But I do also support an alternative syntax in the test file that's this way. So the C data section can also be represented by an opening brace, then an indented section, then a closing brace on the final line. So the nice thing about this is that you need no escaping, because what marks the end of the C data section is the fact that it's less indented. And you'll see why it's useful. So I do have a script that I've been using for almost 8 years for my own needs. Every time I need to review something in an XML file, I just convert it. It's much easier to review when it's converted using the script. And since it is XML, even after conversion, you can make a change to fix something, convert it back, and you get real XML. So I'll make a quick demo. So, for example, if you have let's see, for example, XSL is a language that's very difficult to. I made the wrong conversion. It's the other way around. This is interesting. So you have that's the original XML. And after conversion, that's the way it looks. And so after conversion, the XSL looks like a reasonable programming language. If you compare it, you see the difference. You see on the left you have the original XML, on the right the thing. And here, anyway. Or, for example, another example is you have the key. How much time do I have left? Let's look at the clock. Anyway. So the script works well because I've used it for many, many years, but it's not really performance. It doesn't really matter because usually I work with files that are just a few kilobytes long. Now, the second thing I want to demo to you is a related script that I used to explore. Initially, it was to explore the /proc file system in Linux. When we had problems with Lustre, usually the solution was somewhere in /proc//ls/Lustre. And I started working on a script to display a tree of files and look for whatever can look wrong over there. So the script is called show, and it will show you the contents of a tree. So here I have a directory which is called show demo. And every file is converted to, so the output of the script is almost like the XML syntax I showed. Actually, it can be, if I remove the decoration of the slash, which represents the directories. So if I remove that, this is XML.
On the element names?
Yes, because you see that the slash is illegal in your element names.
What about special characters and
Wait,
spaces?
I'll come to that.
Okay, sorry.
Okay, so this works well because I've chosen carefully the file names in this example. But then you can convert that to XML and then process it if you need. Now, that script, I do have an option actually to handle the case of long file names. And So here's how it works. In this case, if you use this option, the name will go into an attribute. Okay? So you have the object type, which is directory or file, and or even a link, and so on. And the name goes in that attribute. So and then so it's really nice when you explore /proc, especially when you don't know beforehand what files are available there. So I've been doing that quite a lot. And now you can see, for example, you can see here that this C data is not really friendly, and so this script has all the options for experimenting with the alternate syntax. And looking this way, it's much more friendly. So you have the beginning of the C data section and the end of the indented C data section, and then it's readable in a really optimal way. So now, why do I talk about this? The reason is that you have, why would you want to work with a format which is different from XML? Well, because if you need to extract data from these structures, if it were an XML output, it would be very easy to extract data from that in the XPath. If you want to reinvent something to extract data, whether it's JSON, whether it's your own language, it's a huge work usually. So if I wanted to write a script to extract data, it would be difficult. But since I chose something that is just a different presentation of XML, extracting data from such a file format is very, very simple because it can be done with a single line script, which is convert to XML, then use any existing tool that works with XML, and you're done. That has actually happened to me because I was doing some work where, for my own use only, which means output things in this simplified format. And people came to me and said, well, we're interested by your tool, but we need to process it, and how can we read it? And I said, well, easy. Okay, so I'll demo. So if I list the files in the directory 1, I'll come back to the first one, for example. And you see that the file called, for example, hello, just a trivial example. Now, if I use the XPath program, the XPath program is designed to extract data from an XML file using just XPath. So it's a trivial loop, trivial wrapper around TCL's TDOM library. So it will, you just pass it. The program works by passing commands that sounds like the Linux or Windows command. Like this, so find /world/country. 5 countries in my file. So, oh, capital. I think you get the point. maybe they are at a lower level, and you have many capitals. Now, you can use cat and get the data from the XML elements. Now, the nice thing about this is that I was using show. So here's a reminder to show you this in this simplified format. So it's very nice for exploring as it is. And if I convert it to XML, then I want to extract something. So expand. The command. Oops. Open file. That's bad. You got it? So you see the benefit of using such a format for data output is that any tree can be both read very easily by a human, like in this example, and also it can be processed very easily by a program that knows about XML. Okay, now I'm on size. So I've tested the program on all the XML files I could get a hand on, and the side benefit of doing that conversion is that the converted files are smaller. And so the benefit varies depending on the structure of the file. You know, the very simple files with just CData elements have little benefit in the conversion, whereas the files with deeply embedded elements like KML, for example, get really much smaller. It's the same for example, this PowerPoint presentation. Internally, it's an XML. It's a set of HMS files actually, and I just played with that. And PPTX is a set of XML files and included in a zip file. And after converting them and re-entering in a zip, even that you get a smaller size. So this is just a kind of a joke, because I don't think Microsoft will change their file format, but they could very easily, they did, because you could change nothing basically to Word or PowerPoint. It's just a simple conversion of the output. And now, personally, I've been using it a lot in my own diagnostics program, for example, for outputting data, because it makes the output much more easier to read, and it allows to post-process it with the program easily as well. So some people, I'd be interested in getting feedback from others to see what they think about it. Now, among the other things, I never used SOAP. I remember having a class about it, and I remember thinking it's really horrible to review. So if you convert a SOAP envelope using this, it will look much better, believe me. You can give it a try. And since it takes less, it's much smaller as well. So for the network protocols, I think it would make sense to use this presentation of the structured tree instead of pure XML. Okay, just a quick side note. I suppose people use the double common syntax for namespace for borrowed it from C++, I suppose. And I really wonder now why we didn't choose to use the forward slashes for the namespace, because all these trees are just the same, and for me,
The answer is C++, I represent.
yeah.
But you're right, I agree.
had a parsing library, and I don't have one. Because in simple cases, when you have data without attributes, the output is an XML tree. It is an article tree, or article list, or whatever, or article list of lists. I'm talking about simple cases where you have a parameter and a number, a parameter and a number, things like that, which is very common when you have to monitor machines, which was my problem. And in the rare cases where I needed to access more complex data, well, I just converted it to XML and I put access in the program. If I were to rewrite the conversion program, what I'd like to do really is to start from the key-DOM of the source and just modify the parsing routines, because it's the parsing of the DOM which is hard in T-DOM, I think, but the parsing of the presentation is probably a minor part of it. Same thing the other way around. And that's it. So, anybody interested in getting feedback on this, what people think about it, if you think it can be useful to others, and if the rules are listed, which aren't that many, look good, and I'd be interested, if there are people who have experience with the TCL DOM or T-DOM sources to talk about them, to see if it could be adapted as I think. Okay, and the last two is, well, I've used it for many years, and using it, the more I use it, the more I'm happy I did that, because every time it saves me time. So I wanted to share that with the community.
Would you like to rewrite it in JavaScript?
No, in JavaScript, they did JSON, which is naturally adapted to JavaScript. But
well, I'm just wondering what the relationship. This would be with XML as well. It's obviously a redundant question, but have you got back and forth to JSON?
I've not tried, but JSON, the thing is that I don't want to go. I don't want to do an alternative to XML. I just want to keep working with XML, but without the pain of having to read the convoluted syntax with all those brackets and so on. That's all.
I had a similar experience. We had an XML-based application we had to talk to, but they had their own parser, so it had its own rules. So to be able to communicate back and forth on a timely basis, I ended up converting their XML into key value nested tree form.
Yes.
And I'm like, wow, I'm not the only person who does that. Yes.
Yes, also the TDL proposal on the wiki, on the TCL wiki, is like what you said. So that it's a pure TCL list with the tag name, then the attribute name, and the attribute value, then the attribute name, and the attribute value, and so on. So in that sense, it's easier to parse by TCL program. But I've tried that, and honestly, I think it's less readable in the long term.
Can we take questions afterwards so we can try to get back on time? Okay, thank you.